All right, let's try to finish this up. Now, I think yesterday I said that was our last time doing a new lesson, and I lied. Well, I didn't really lie. I just thought we might, finish that lesson yesterday, but we didn't, so we're going to finish it today. So what are we going to talk about today? What's the big thing? It's the unit circle. Unit circle. Actually, we are going to do some triangles within the unit circle, okay? So you never get away from triangles. Can you imagine when you're a little tiny kid, right, and you're learning your shapes and you learn triangle? You had no clue back then about how complicated, how many things you could learn about a triangle. Wouldn't you agree? Because my grandson, he'll be 3 in June, so he's getting close to being 3. He's learning all kinds of stuff. Everything's new to him, trying to teach him his shapes and all that kind of stuff. So he's got this little puzzle with the shapes, and it's got a little parallelogram in there, of course. I'm like, his name is Brink. Did I ever tell you that? So I do too. So anyway, I'm like, oh, Brink, come here, let's do this. This is a circle, and he's a circle. This is a triangle, And I said, this is a parallelogram. And so my wife's like, what? What are you teaching that for? I'm like, it's what it is. It's a parallelogram. I said, this is a trapezoid. And I said, trapezoid only has one pair of parallel sides. And my wife's just shaking her head, just like, all right. I mean, I do that kind of in jest. I'm not expecting him to remember that kind of stuff, but I just think it's funny. All right, enough of that. Unit circle. So we need a circle, don't we? So let's push that out of the way just so we have a big old circle. Hit shift. You know what the shift key does when you make a circle? It doesn't just make it bigger, keeps it a circle, because watch. So if I just hit the circle tool, right? If I just click and drag, see I'm not hitting the shift, see it just makes an ellipse is what they call it, or an oval, some people call it, right? But watch this, as soon as they hit shift, watch, boom. See what it did? It makes it into a perfect circle. Now you do. So like even in, I guess, I don't know, I don't use Word that much, but even in Word you could do shapes, and my guess is maybe, I don't know, they might just have a button that's just a circle and it doesn't change the shapes, but that's what you do. All right, so let me put center right there. And let's put an X and Y axis on this. There's the X axis. There's the Y axis. Wow. Almost nailed it right there. Now it's good. Okay, so this is a circle, and it's a unit circle. So Ashton, tell me what's true about a unit circle.
Something about the thing being 1.
The radius is 1. Come on, we just talked about it 5 minutes ago. Yeah, that's what I thought. All right, so when the radius is 1 on a circle, we call that a what? A unit circle, okay? Unit means 1. There was a picture back in the day, Randy Johnson. Anybody heard of Randy Johnson? He was real big, he's like 6'7" or something like that. 10? You're probably right. He's probably closer to 6'10". Great picture. He actually killed a bird with, you ever see that clip? Where he's throwing a pitch and this bird flies across, like it disintegrates. I mean, it's amazing. But anyway, Randy, well, I mean, sorry for the bird, but it was just incredible that, I mean, he didn't do it on purpose, obviously, but anyway, that's Randy Johnson. His nickname, by the way, the reason I'm saying that, his nickname was called the Big Unit, right? He's like the number 1 guy, right? The big number 1, basically, is what they were saying, all right? So anyway, he's the big unit. So unit means 1. So the radius of this circle is 1 when we talk about a unit circle. So let's do this. We said earlier, we're going to do some triangles. Let's do it right now. So I'm going to take where it hits. I could have taken this radius anywhere on the circle, okay? I stayed in the first quadrant just because it's a little easier to see in the first quadrant. Everybody looking up here? I got a lot of people that are dazed already, phased out, all right? I want you to concentrate. Look up here. So this is the radius is 1. So where it hits the circle right here, what I'm going to do is I'm going to drop down a perpendicular to the x-axis. Everybody see that? To the x-axis. All right, and let's do, we'll do red, it doesn't matter. And now what I'm going to do is draw from here. I just want to give myself two different colors for these two sides of the triangle. Is that all right? Okay. We'll call this angle theta, right? Because we don't know what that angle is. Now watch. Make sure if did I click on that? Where is it? I don't know. Did I click on it? Nope. Nope, don't want that. Oh, it must be behind there. I'll just go red like this. Okay, sorry. This is going in the x direction, so I'll call that x. And this is going in the what? Y direction, so I'll call that y. Everybody see that? Now, I want us to take a look at something. Remember sine, cosine, tangent, right? All right, we're just going to do the sine and cosine right now. Let's do cosine first. Let's go back to white. All right, so what if I wanted to find the cosine of that angle? What is the cosine? What over what? It's adjacent over hypotenuse, right? So it's adjacent, which is x, over the hypotenuse, which is 1. So it's adjacent x over 1. So what is the cosine? It's just x, isn't it? All right, so let's just do it like that. Simplify it. So the cosine of the angle is equal to that length right there. Whatever that length is, that's the cosine of the angle, if it's a unit circle, okay? What about the sine of the angle? It's equal to what over what? Opposite over hypotenuse, correct? So this would be y over 1. But instead of putting over 1, what could we say? We could say it's y. So let's think about this ordered pair right here. We started at the origin. We went we went x number of places, right, in the x direction. Then we went y number of places. So what would the ordered pair right here be? It'd be xy, correct? You could also write it as, look, since x is equal to the cosine and y is equal to the sine, how else could you write this? That's it. You could write this, oops, let's make this a little bit better, parentheses, cosine, sine. All right? So this is super important, all right? Now, we got a lot more we could do. This is our last time doing something new, though, so I'm trying to cram it all in, right? So this point right there, okay, is the cosine and sine, right? So let's do something before I do what was in my notes. What if, let's go different color. What about this point right there? What is the ordered pair of that point? Remember, it's a unit circle. So from here to here is how far? It's 1. So what's the ordered pair to that point? 1, 0. Good. You with me on that? Okay. So here's the thing. And what degree am I at right here? Remember, we always start here and we go this way. So what angle am I at right here? Like this would probably be like 60 degrees or something, okay? But what degree would this be? It'd be 0 degrees, wouldn't it? Okay. So watch this. If I asked you what the cosine of 0, let's almost make that into a theta, 0 degrees is equal to, what do? We look at the ordered pair. Which one is the cosine? The x. It's easy to remember because the ordered pair xy, it's in alphabetical order, correct? Cosine sine is in alphabetical order, right? So it's pretty easy to remember. So if I said the cosine of this angle right here, because this is an angle, right? It's just horizontal, right? But it is an angle, 0 degrees. What is the cosine of it? All you got to do is look to that first number in the ordered pair. So what's the cosine of 0 degrees? It's 1. What's the sine of 0 degrees? It's 0. Put it into a calculator and see. Anybody got a calculator out? Somebody get a calculator. You should have it close by. It's probably in your book bag right next to you. So put in the cosine of 0 degrees. What do you get? You get a 1, don't you? All right. Put in the sine of 0 degrees. What'd you get? A 0. But we could figure that out without even using a calculator. Isn't that cool? All right. Let's do some more. Let's do this angle right up here. What's that angle? How many degrees is that angle? It's 90 degrees. Again, we always start from here. All right, we always start from here and we're going in that direction. So that would be a right angle. Agreed? So this would be 90 degrees. What's the ordered pair at 90 degrees? It's 0, 1. All right, so what if I asked you for the cosine of 90 degrees? What would you tell me just by looking at this ordered pair? It's 0. That's right. Angela, am I right? Yeah. What if I put the sine of 90 degrees? What's that equal to? It's equal to 1. Let's do it for a couple more. All right, I'm not going to write every little thing down like I have been because I got a couple more I want to do. Well, maybe I will because I'm going to do the other stuff on another circle. What about this point right here? How many degrees is that? Again, we're starting here and we're going to go all the way to here. What is it? 180 degrees. All right, what's the ordered pair? If this is a unit circle, it's what? It's -1, 0. So what's the cosine of 180 degrees? It's -1. Try it. Cosine of -1 or 180 degrees should be -1. What's the sine of 180 degrees? It's 0. By the way, let's do one more. I said we weren't going to do this, but we'll do some different color. What are we missing here? We did sine, cosine. What's that? Tangent. What about the tangent of that angle? Well, what's the tangent? It's what over what? It's opposite over adjacent, or y over x. Or we could write the tangent as the sine over the what? The cosine. Probably should put theta right there. That's okay. All right? So that's kind of interesting. That's something new that we didn't talk about before. So the tangent is equal to the sine over the cosine. All right? Or the y over the x. So let's go back to the 0. What would the tangent of 0 be equal to? Again, it's the sine over the cosine, or the y over the x. So what are you going to do? You're going to look at the y, look at the x. So what is that? It's 0 over what? 1. What's 0 over 1? It's 0. So what's the tangent of 0 degrees? It's 0. So you can find all these without using a calculator, but we're putting it in a calculator just to kind of verify that I'm telling you the truth. Would you agree? Tangent of 0 is 0. Now, here's a weird one. What about the tangent of 90 degrees? It's undefined. That's right, because it's sine over cosine, or y over x, or 1 over 0. Can you divide by 0? No. So what does your calculator say? It says error, right, which means it's undefined. All right, so there is no tangent of 90 degrees. It's not 0, all right, because it's 0 at 0 degrees, but it is 1 over 0, which is undefined. A lot of times they write undefined as the empty set. You could write it like that, or you could write the word undefined. It's fine. Okay, you with me? All right, so what is the, we already said that. So let's just do the tangent of 180. We didn't write it down, but we talked about the sine and cosine of 180. So what is the tangent of 180 degrees? It's what? 0 over -1. What's 0 over -1? It's 0. So the tangent of 180 is the number 0. It's not nothing, it's the number 0. What about this one right here? How many degrees is that? 270. Very good. Because it's 180 plus what? Another 90. All right, that's 270. What's your ordered pair at this point right here? 0, -1. Okay. What's the cosine of 270 degrees? 0. Just by looking at this unit circle. Unit circle is super important. It's crazy important, okay? And there's so much more that we're going to do with it than we can do in this one class period. But at least we're getting a taste for it. You know what I mean? So what is the cosine of 270? It's 0. What's the sine of 270? It's -1. Again, if you wanted to, you could put it in the calculator and see. What is the tangent of 270? It's the y over the x, or the sine over the cosine. So you're dividing by 0 again. So what's the tangent? It's undefined. That's right. Okay, so it's undefined up here, and it's undefined down here. All right? So that's kind of interesting, don't you think? Yeah, I think so. Let's do this and that. We'll copy that. All right. So now we're really going to get into it now. By the way, they give it a fancy name. Those angles, 0, 90, 180, 270, they're called quadrantal angles. Quad because there's quadrants, right? They lie right on the x and y axis in those quadrants, okay, or on those quadrants, like whatever. All right, so there you go. So now let's do another one, and this is kind of cool. And I'm going to show you a video today. It's only a 5-minute video, but so at maybe 5 till or 2, depending on how long it takes to do this, I want to show you a video just to kind of bring it all together. It's pretty good video, I think, to see this. So what if I had an angle, and I knew that angle, it's not theta this time, still a unit circle. So what's the hypotenuse or the radius? It's 1. When I say hypotenuse, it's the hypotenuse of what? That right triangle, okay? Again, what did I do from there? I didn't go over to the y-axis. What did I do? I dropped it down to the x-axis. That's super important, okay? And this time, let's say it's 30 degrees. So what I'm going to do is I want to find what the cosine of 30 degrees is and what the sine is of 30 degrees without using a calculator. All right, there's a lot of special ones, a lot of special angles on here. We've done 4 already. We did 0, 90, 180, 270. Now we're going to do some of these other ones that we've learned, okay? And we learned in geometry about a 30, 60, 90 triangle. Do you remember that? The short side, the hypotenuse is twice as big as the short side. So what's the short side then? It's a half. And we learned that the longer side, or the longer leg, is the square root of 3 times the short side. So what's the x going to be? Square root of 3 over 2. Everybody see that? So now, just knowing that, I should be able to figure out what the cosine of 30 degrees is equal to, what the sine of 30 degrees is, and you could also find the tangent of 30 degrees. Just by thinking about this this unit circle, this right triangle inside the unit circle, okay? Everybody with me on that? We didn't need a calculator for any of that. So the cosine of 30 degrees, which one of these is the cosine? The x is, which is what? What's the number? Square root of 3 over 2. Square root of 3 over 2. You didn't put your calculator away, did you? So some calculators will give you square root of 3 over 2, but most of them will give you a decimal. I think it's like 0.8660 or something. I don't know. What is it? Is that what it is? Square root of 3 over 2? Cosine of 30. 0.8660. I was correct. So watch. So it's 0.8660. All right. So if you put in cosine of 30 in your calculator, you're going to get this. If you put in the square root of 3 over 2 in your calculator, you're going to get this. So would you agree that they are equal? Yeah. What's the sine of 30 degrees then? It's just 1/2. What about the tangent of 30? How do I find the tangent of 30? It's the sine over the cosine, which is 1/2 over square root of 3 over 2. All right, we've got to do a little bit of work with this. So it's 1/2. Instead of divided by, we're going to multiply by the reciprocal. So that's 2 over the square root of 3. The 2's cancel. I got 1 over the square root of 3. Can you simplify that by rationalizing the denominator? Square root of 3 over 3. I was watching a video by this guy in Australia, and he was teaching a class this. It's just their terminology sometimes is so different. They use this terminology. They said 1 on root 3. So if I said 1 on root 3, if I just said that, you probably wouldn't understand what it means. But this is what it meant. Okay, 1 over square root of 3. So if I said that to them, they would probably laugh at me. But when I hear them saying 1 on square root of 3, because it's on top, right? It's on top of it, I guess. That's why they say it. Anyway, I just thought that was kind of funny. Mia Felice, she always says root 3 or root 2 because that's what her teacher always said. And that's fine. I think we've talked about that before, haven't we? And that's fine. But I say square root. But most of the time, they want you to simplify it like this, rationalize the denominator. But that Australian teacher was fine keeping the answer like that. All right. But a lot of times, I don't know when they want you to do it one way or the other. But for the most part, ever since I was taking math, this is how we always write the answer. All right? And again, I don't know what that is off the top of my head as far as a decimal, but this is the same thing as the tangent of 30 and square root of 3 over 3 is. Okay? Let's do another one. Let's do let's do a 45. Well, yeah, let's just go to 45. Now, let's do this. Let's go back up to here. And let's just change the color just so it pops a little bit since I'm using the same graph. What if I did this angle? What do you think that angle is? I don't know exactly. I mean, I'm just kind of guessing. So that would be, there you go. So this would be what? 60 degrees. Now, if you look at this, on a 30 and a 60, the shorter side is a half, and the longer side is what? Square root of 3 over 2. So do we have to go through all that again? What is the shorter side right here? That would be a half, and this is the longer side. What would that be? That'd be square root of 3 over 2. So what's the cosine of 60 degrees? Cosine. Cosine goes along the x-axis. So it's 1/2. That's right. So you can put it in a calculator if you wanted to. Cosine of 60 degrees is a half. The sine of 60 degrees would be what? Square root of 3 over 2. All right. Now the tangent's a little different. Let's just do the tangent of 60 degrees. So what's the tangent? Sine over cosine, or opposite over adjacent, or y over x, however you want to look at it. Okay. So it's going to be what? Square root of 3 over 2 over what? 1/2. We simplify it, so we write square root of 3 over 2 times what? 2 over 1. 2's cancel. That makes it nice. Don't have to rationalize the denominator. So what's the tangent of 60 degrees? It's just the square root of 3. Okay? These are numbers that you should, in the future anyway, because we're not doing a whole lot with this, because this is the last time we're going to do this stuff today in this year. But it's in the future, it's very important to memorize those numbers. Memorize a half, square root of 3 over 2. I think I told you a while back. See that square root of 3 over 2? That's a number that you're going to have to know. It's going to be very important, all right, and that kind of thing. We good with that? Let's do a 45. And yeah, we'll keep it blue. And 45 is probably about right there. All right, we'll drop that down to the x-axis, perpendicular, okay? And let's say this is 45 degrees. Remember, that's 1. Do you remember what the relationship was between the legs and the hypotenuse? Remember, the hypotenuse was the square root of 2 times the leg, all right? So if I know the hypotenuse is 1, how do I find the leg? We'll call it x. Divide it by what? Square root of 2. What's that? 1 on root 2, right? Or 1 over the square root of 2. Rationalize the denominator. What's that going to be? X is equal to what? Square root of 2 over 2. Right? You following me? Okay. So this would be the square root of 2 over 2. Now look, I don't have to do it again for this because what? It's 45 degrees, so this side and this side are equal. So what's this side going to be? Square root of 2 over 2. Same thing, right? Okay. Now, I can ask you those questions again. Okay, what is the cosine of 45 degrees? Square root of 2 over 2. What's the sine of 45 degrees? Square root of 2 over 2. Put it in the calculator, check it out, all right, and it's the same exact thing. What's the tangent? We've got to do a little tiny bit of work with that, so I'll write it out. Tangent of 45 is what over what? Opposite over adjacent, sine over cosine, y over x. So it's something over itself. What's anything over itself? It's just a 1. So the tangent of 45 is just 1. So that's kind of cool, isn't it? All right. What if we do this? We're pretty good on time, actually. Can't believe it. Famous last words. What if I did this? What angle is that orange one right there? Again, with the positive x-axis. So I'm looking at that angle right there. I got to tell you this, sorry. That's 45 degrees. It's 135. Very good, because you went 90, and then that's 45. That's 45. You want another 45. Or you could do this. Go all the way to 180 and then subtract the 45 from it, right? It still gives you what? 135. So here's some other angles. Remember I said there's a bunch of angles we could think of and we could figure it out without using a calculator, okay? We can do this in our head. Eventually, well, if we were going to keep on using the unit circle, which is the last time, but if we were going to keep on using the unit circle, you should just be able to visualize that unit circle and tell me every combination of 30, 60, and 45, the sine, cosine, and tangent of any of those combinations around that whole entire circle. So 135 is one of those combinations. Agreed? It's a 45, isn't it? So what are we trying to do? Trying to find that ordered pair, correct? So how far over did you go? It's 45, so we went over what? It's negative. Very good. I'm glad you said that. Negative square root of 2 over 2, didn't we? To go from here to here. And then we went up, how far? Positive. We went up, so it's positive square root of 2 over 2. So what's our ordered pair at 135 degrees? It's negative square root of 2 over 2, positive square root of 2 over 2. Right? And so now, what am I going to ask you? The cosine, sine, and tangent. What's the cosine of 135 degrees? Negative square root of 2 over 2. What's the sine? It's positive square root of 2 over 2. What's the tangent? It's a negative 1 because it's y over x. It's something over its negative counterpart, right? So that would be a negative 1. See how easy it is to figure out these special angles? Now, if I gave you something like 43 degrees, it's not going to compute, okay? That's when you put it in a calculator, all right? But you do have these special angles. Any combination of 30, 45, and 60, all right, you should be able to find the sine, cosine, and tangent of without using a calculator, all right? And that really can be helpful. Let's do another one. Oh, we did the radian thing, didn't we? Didn't we learn about radians the other day? Yeah, okay. So what if nah, it was good enough. Let's do one more. What if I asked you I pretty much covered everything. Let's just pick one in another quadrant. Let's say 300 degrees. Okay, what if I asked you, that's at 0. Oh, that's terrible. Let's do it again. 0, 0. What if I asked you for the sine, cosine, and tangent of 300 degrees? How would you find that without using a calculator? Everybody watching? Okay, because you should be able to. You might be able to do it in your head, but not at first. When you first learn this stuff, you're not really going to be able to do it in your head. All right, let's draw the unit circle. So you can just do a little sketch like this. Draw an x and y axis, put a circle in there, center it at the origin. And then where is 300 degrees? Is it, well, there's 0, right? And then that's 180, and that's 270. That's 360. So what are we going to do? Back it up 60. Or you could go 270 and go how much further? 30 further. However you want to look at it, okay? Does that make sense? So that's where 300 degrees is. And then I'm going to pop this up where? To the x-axis. Always take it to the x-axis. Don't take it to the y-axis. You with me? So what's this ordered pair right here? This is a 30, 60, 90 triangle, isn't it? So that's 60, and that's 30 right there. So that's the short side. So when you have a 60-degree angle or a 30-degree angle, the short side's always how much? It's a half. Don't even have to go through the work anymore, right? We kind of memorize these numbers. So the short side is a half. The longer side is how much? Square root of 3 over 2. But this is going what? Down. So this would be a negative square root of 3 over 2. This is a positive 1/2 because we're going to the right. So what's your ordered pair? It's 1/2 negative square root of 3 over 2. So now finding the cosine and sine is super easy, isn't it? What's the cosine of 300 degrees? Just 1/2. I can just look at it now, can't I? What's the sine of 300 degrees? Negative square root of 3 over 2. Again, I can just look at it, right? I just do a little sketch. Doesn't take long. Do your little x and y axis, put a circle, 300, kind of figure out where 300 is, right? And figure out this. This right here was super important, finding that angle, right? Draw your little right triangle. Doesn't have to be perfect, all right? But make it as accurate as you can, even if you're just hand drawing it. But know that that's a 60-degree angle. Know that that's the short side. Know that that's the long side. If you can do that, you can figure out what the sine, cosine, and tangent of 300 is. Now, do you remember on a 60? Do you remember what the, I'll tell you what. If you had the tangent of 30, what did we say the tangent of 30 was? Look in your notes. What was that? Wasn't it the square root of 3 over 3? And then we found the tangent of 60 is what? Just the square root of 3. Now look, 30 is smaller than 60, isn't it? Square root of 3 divided by 3 is smaller than the square root of 3. So I know that the square root of 3 over 3 goes with the 30. And then I also know that the plain square root of 3 goes with what? The 60. So this is the 60. So what's the tangent of 60? It's just the square root of 3. So the tangent of 300 is equal to, it's actually not equal to the square root of 3. What is it? It's opposite over adjacent, so it's negative over a positive, which will mean what? It's a negative square root of 3. All right, so punch it in your calculator. Do it real quick. Put the tangent, square root of 3 is like 1 point something. 3 square root of 1.73 something. Would you agree? It comes out to negative 1.732, blah, blah, blah. Yeah. What do you think? That's pretty cool, isn't it? I think it's kind of neat to see how all that works. All right, I said I was going to show you a little video, right? A couple of things on the video you may not know, but a lot of it should be familiar from what we just talked about right now. Let me go back to this. I'm going to change this a little bit. What's that? No, it's not the Australian guy. All right. The sound may not be so great if you're watching this on YouTube, but you can just look at it. Type that in. Learn unit circle radians in less than 5 minutes. Type that in. You can watch the video yourself. All right. Oh, I got to plug up the speaker. Hold on. It's only 5 minutes, and we'll be actually finished early. How about that? That's the first, isn't it? Doesn't usually happen. All right. Here we go.
Learning radians can be pretty easy. It's a little bit like cutting a pizza. So watch me slice this up. Hey, welcome back. This is Tammy and I do math for coffee. Okay, we have to start by talking about the circumference of the circle first. So starting with the whole circle, the formula for circumference is 2 times pi times the radius. Well, in the unit circle, the radius is 1, so the circumference is going to be 2 pi. Going all the way around this circle one time, that equals 2 pi. And that's radians. That's the basis of radians. The basis of degrees was 360 degrees as a full circle, but in radians, we know a full circle is 2 pi. So let's do a little more with that. The unit circle, we know it has a radius of 1. There are an infinite number of points on the circle, but the unit circle has 16 points that are super interesting. And the very first one is at 0. But 0 is also 2 pi once you go all the way around once. Now I'd like you to split that circle in half. And if you split 2 pi in half, you get pi. Now I'd like you to split the top in half, and if you take pi and divide it in half, you get pi over 2, 1/2 pi. Count to yourself 1 pi over 2, 2 pi over 2, 3 pi over 2. That is the 4th point. All right, let's find the rest of the points. We're going to start with this 30-degree angle, and I want you to think about this. You know that this is 180 degrees, and so this whole top part has how many 30-degree angles in it? It has 6 of them. So that means pi is split into 6 parts. Well, that means each one of these little sectors is pi over 6. So let's look at the angles. The very first one is 1 pi over 6. The second one is 2 pi over 6, but that's not in lowest terms, and so we're going to put that in lowest terms, and this one is going to be pi over 3. The third point, we already know what that point is. 1, 2, 3 pi over 6's. If you reduce that, it's pi over 2. That should look familiar. The next one, this is 4 pi over 6. 1, 2, 3, 4. We have 4 sections, so it's 4 pi over 6, also not in lowest terms. So we're going to write it down as 2 pi over 3. The next one, 5 pi over 6. That is in lowest terms, so we'll just leave it there. The next one is 6 pi over 6. This reduces to pi. Then the next one must be 7 pi over 6. This guy down here is 8 pi over 6, also not in lowest terms. So when we do that, it becomes 4 pi over 3, but it started out as 8 pi over 6. I hope you are seeing the easy way to remember this. You just set it up in the sixes and you count. So the next one would be 9 pi over 6, and that reduces to 3 pi over 2. We already met that point before, so okay, but now it still works. Like you can just count up by the sixes and you're going to end up with 3 pi over 2. So the next one should be 10 pi over 6, which reduces to 5 pi over 3. There it is. If you're following the pattern, you know what the next guy is going to be. 11 pi over 6, already in lowest terms. We don't have to do anything more with that. And if we close this circle, we end up at 12 pi over 6, which reduces to 2 pi, which is what we expected, right? This last set of points is going to be based on what happens when you divide this circle up into 45-degree angles. And 180 is the same thing as pi radians. Each sector is going to be pi over 4 in size. So the first radian will be pi over 4. The second one is going to be 2 pi over 4, which needs to be reduced to pi over 2. Again, we know that one already. 3 pi over 4, again, we're counting up. 1 pi over 4, 2 pi over 4, 3 pi over 4. This one's fine, it doesn't need to be reduced. Then 4 pi over 4, and that's going to reduce to pi. Moving down south, we have 5 pi over 4. This one is going to be 6 pi over 4, which reduces to 3 pi over 2. Again, there's repetition here, but depending on how you count up, you're going to land on that point again. That has to be 7 pi over 4. That doesn't reduce. Closing the circle, we end up with 8 pi over 4, which reduces to 2 pi, which is no big surprise, right? All right, let's put it all together. Now for the next thing we need to learn is how to find the coordinates for each one of those points. Watch that video next. Hey, I'm Tammy and I do math for coffee, and we are diving into the unit circle. I'm going to show you an easy way to find all the coordinates. So first of all, think about your unit circle on a coordinate graph with the origin right here at the center. We know the radius is 1. This point would have to be 1, 0. This guy up here, x equals 0 and y equals 1. This third point, the coordinates would be -1 and 0, and the fourth point would be 0, -1. So we have 4 points with coordinates right now. Now we need to find the others. So we know that that first point that comes up off of the 0 that shows up on our unit circle is associated with a 30-degree angle. And the reason I was bringing in the special right triangles here, we can use what we know about special right triangle.
Now they do this. Oh, my mic. Okay, so they do this a little different. All right. They make the short side A, but it's a unit circle, so it's to me it's a lot easier to do the way that I explained to you today. So to me it's a lot easier to make that a 1, but still it'll all come out to the same in the end. All right, and if you just memorize the short side is a half, the long side is square root of 3 over 2, it just makes it a lot easier than what she's doing.
To be able to come up with the coordinates of the point. Special right triangles have ratios of their sides, and we know that the shortest side is going to be across from the smallest angle, so that's the A, whatever this is. goes over there. The hypotenuse will always be 2 times that number, and the other leg is going to be that number times the square root of 3. So we know we're also in a unit circle, so we can figure all of this out. There's no mystery here. Let's zoom in and take a look. We know that the radius is 1, so that means the hypotenuse is 1, which means 2a equals 1. Do a little math, divide both sides by 2. A is 1/2. Okay, well, we know that the side right here is 1/2. Now I want to caution you, this triangle doesn't go all the way over to the circle, so I know that the 1 is the hypotenuse and not this leg here. It doesn't make it all the way over. Take the 1/2 times the square root of 3. Multiplying those two out, you get the square root of 3 over 2. The coordinates of the point have x, y coordinates, and the x is going to be the horizontal movement, and the y is going to be the vertical movement. And since we know the sides of these triangles, we know that x has to be the square root of 3 over 2, and y is 1/2. That's the coordinate for this first point in the first quadrant. Now, if you saw the other video, I'll link it up above if you haven't seen it yet, we know that there are 4 other points on the unit circle that have to do with this 30-degree triangle, and there's 1 in each quadrant. The second quadrant angle is 150 degrees, and the coordinates will be the same, except that you're going to go backwards on the x and up on the y. So the x is negative, the y is positive, and you just use the same coordinates from first quadrant. You just make the signs what they need to be. So in this case, it'll be a minus and a plus. You go down to third quadrant, it's going to be the same numbers. It's just that everything's negative down here. The angle is 210 degrees, but the coordinates are both negative. Same numbers, just the signs have to change. Moving over to fourth quadrant, oh, I made an error there. Right now we're going to be looking at the 45, 45, 90 triangle when it is inside of the unit circle. And again, the hypotenuse is going to be the radius of the circle, so we know the length of that is 1. When you are using a 45, 45, 90 triangle, this is isosceles. Both of the side lengths are the same, and the hypotenuse...
All right, you get the idea. I mean, she's basically saying what I said, okay? She's doing 7 minutes. It took me 40 minutes to do or whatever. I want to show you one more thing. Oops. Let's go to this. Is it in downloads? Yeah, there it is. Did I show you that already? I already showed you this? Okay. What I didn't talk about yesterday, we talked about the radians, changing radians to degrees. Okay. And they don't say it here, but they put the ordered pair, so you can just look at this chart and say, what is the cosine of pi over 6? Just looking at this chart, what is it? What's the cosine? Square root of 3 over 2, that's right, okay? Now they don't put this on here, but what would the tangent of that be? Remember, this is 30, it's the smaller one, or pi over 6, which is a smaller one. So what's the tangent of that? Square root of 3 over 3, good. Make sense? So this is kind of handy if you had something like this. I did say I was going to print it out. I forgot. I'll try to do it after school today if I remember. All right. But like you said, there's one in the book, right? Yeah, there's one in the book. It probably doesn't have everything in here, but you get the idea of what this does for you. Okay? Everybody good? Finish up that 1 to 33 if you didn't, because you probably wouldn't be able to, right? Because of the stuff that we did today. So if you're turning it in right now, I'm sure you have questions about some of the ones towards the end. All right, so get those done because I just taught it today, and then we'll turn it in tomorrow. What's that? Have I not collected it yet? Yeah. So yeah, what was the one you're turning in? I mean that I'm giving you a 10-4. Okay, so 10-3 I will take. So I will take 10-3 if you have that, and then 10-4 I'll take tomorrow. Okay. Yeah, that's fine. That's fine. I probably won't grade it anyway, so until the weekend is my guess. All right, enough of that.